Before planets and stars were born in the universe, a lot of hydrogen and helium atoms were floating around. These atoms eventually formed clouds of gas that developed their own gravity. As the gravitational forces grew stronger and stronger, the stars were created. 4.6 billion years ago, the Sun was born. As nuclear fusion progresses, heavier elements form within the stars, such as carbon, oxygen, nickel, and iron. Those elements began to collide, forming dusts and debris, which led to the formation of asteroids, moons, and planets like Earth. Roughly 4.5 billion years ago, the gases that made up the young Earth began to condense into a solid rocky mass of elements. Earth was shaped by the effects of gravity, radioactivity, and physical disturbances like meteorite bombardment and volcanic activity. Around 3.8 billion years ago, the Earth's mantle began to cool, and an atmosphere containing oxygen was born. And because of that, it could sustain life. Before the elements within the Earth began to cool and form layers, their densities determined where they would go. Denser materials like iron, nickel, and other heavy metallic elements sank to form the inner and outer core. Elements such as magnesium and iron silicates, found in denser ultramafic rocks, settled in the middle, forming the mantle. Lighter materials like aluminum and silicon stayed closer to the Earth's surface, forming the crust, mostly made of granite for the continental crust and basalt for the oceanic crust. This process, called Earth differentiation, is the separation of different constituents of Earth materials due to the variations in densities, resulting in the formation of distinct compositional layers. Seismic activity via earthquakes is a way for scientists to understand the Earth's layers without having to find a way to actually dig down and examine them. That's based on the propagation of seismic waves in Earth's interior. Scientists use this knowledge to determine that the Earth's outer core is liquid, since shear waves were blocked by it. However, the inner core is solid, since shear waves travel through it, and that's because of the significant increase in pressure in this ultimate sublayer. Our planet's liquid metallic outer core is vital for the presence of life. In fact, the magnetic field is generated by electric currents due to the motion of convection currents of a mixture of molten iron and nickel in the outer core. These convection currents are caused by heat escaping from the core, a natural process called the geodynamo. Thanks to that, the magnetosphere protects us from harmful solar winds and cosmic rays.